Hello class, so we're going to be talking about the winter break assignment. Alright, so let's try to get started with this one. So here we have this triangular prism with the bottom filled with water. As you can see, the dimensions are here, three units right over here, 5, and then 2 units over there. Okay, and as you can see also here, the water is sipping out 2 cubic feet per minute. Now this basically means dV dt so here dV dt is equal to 2 feet per minute. Now, at any time t, and then h is the depth, and v is the volume of the water. Now, find the volume of the water when it's full. That's rather simple. Here, volume v becomes triangular base. Since this is a triangular base prism, so we have 1/2 base times height, and then times the depth. Now, here we have 1/2 is already there. Base becomes the 2, and height becomes 3, which is right over here, and then depth was the 5. Now, then we get to realize that these two cancels out. Therefore, entire volume would have been 15. Now, since the unit is cubic feet, so we're going to get cubic feet. Now, what is the rate of the change, h, at the instant when the container is 1/4 full by the volume? Now, then let us try to look into this one for a second. In this case, one thing that which we get to realize is this. This depth, no matter what, will always be 5. Only thing that will change is this base and then the height. For example, if you cut across this dimensions right here, then you will realize that we are looking at an isosceles triangle. Here we have this ratio will in fact become something like this. Since this base was equal to 2, while the height was equal to 3, here we have, if I call this one as base, and then height will be base over height will be equal to 2/3. Now, in other words, we get to realize that 3 base is equal to 2 height, 2h. Now, so using this one, we are trying to look at the change in h. That means b should be converted into h. So b will be, in fact, in this case, 2h/3. By putting this one in place of the volume, we'll get something like this. Here we have v is equal to 1/2 times 2h/3 times h times 5. Because no matter what, our depth will be equal to 5. Then these two cancels out. So ultimately what we end up getting is this 5h²/3. Now, that's what v is equal to. But since we know dV dt is equal to 2, So if you have to take the derivative, we'll end up getting dv dt will be equal to 10 h over 3 times dh dt. Then here, we get to realize we need to find out what h is. Here it comes the hint, where the volume was 1/4 full. How can we have the volume 1/4 full? In fact, in this case, since whole thing was 15, 1/4 full would be 15 over 4 must be equal to this volume, which is 5 h squared over 3. Now, when you cross multiply, we'll end up getting h squared will in fact becomes 9 over 4. So therefore h would have been equal to 3 over 3 over 2. Now since h is equal to 3 over 2, all we have to do is plug in that value. Here 2 is equal to 10 times 3 over 2 over 3, multiply that by dh dt. Then here, we get to realize 3 cancels out, and this becomes 2 over 5 will be equal to dh dt. So therefore, the answer becomes 2 over 5 feet and per minute. That's number 1. All right, let us move on to number 2. Here we have f is the continuous function in this given interval, where f of -3 was equal to 4, and f of 3 is equal to 1. And first derivative and second derivatives given in this way. Now, what are the x-coordinates of all absolute maximum and absolute minimum? In this case, the fact that we are looking at absolute maximum and absolute minimum has to be considered by the critical points and endpoints. We need to consider those two kinds. So in fact, here, critical points is when the first derivative is equal to 0 or not defined, such as right here, 1, -1, and 1. Then, here we have, let's call this one as a lower bound, -3, and here it becomes -1. Let's call this one as 1, and here it goes 3, which are the two endpoints. You see, -3 and then 3, those are the endpoints. Here, first derivative is positive, and then negative, and negative. That means the value is going up and coming down and coming down. So only possible maximum point would have been right over here. Therefore, since the function is going up, then when x equals -3 must be lower than when x equals -1. So only possible absolute maximum is at x equals -1. Now, then we have two minimum points. Since this keep on going down, when x equals 3 versus when x equals -3. But we know these two values because when x equals -3, y value was equal to 4. When x equals 3, y value was equal to 1. Therefore, absolute minimum is at when x equals 3. Now, points of inflection is when concavity changes. We see concavity is positive, positive, but here positive, negative. You see the change of concavity. Now, therefore, point of inflection is when x equals 1. Because f double derivative changes from positive to negative. All right, number 3. Okay, so we have to sketch the function here. So I'm going to approximate it a little bit. And then when x equals negative 3, it was equal to 4. So and then one thing that we get to realize is when x equals 3, the value was equal to 1. So we need to come down up to here. Now, in fact, I'm going to bring them down all together. Now, here it goes. Between negative 3 and negative 1, both of them are positive. That means it has to go up, but it's concave up. So that means when you look at the positive concavity, which looks like this, and then where f prime is increasing, that means we are looking at this portion. The function must have gone up this way up until when x equals negative 1, but it failed to exist. And from negative 1 to 1 here, it's negative. But concavity is still positive, so then from positive concavity, the first derivative is negative, then it's decreasing in this manner. So from here to here, we're going to come down. Now, from 1 through 3, both of them are negative. That means we are looking at second derivative is negative, like such as this way, while first derivative is negative. That means it's going down. So this is the portion which we are looking at. So here we have let me be more precise. So it's going to be something like this. All right, let us move on. Number 3. Find the x-coordinate of each relative maximum and relative minimum. Now here, relative maximum and relative minimum can be found by the first derivative. So let us try to find the first derivative together. The 2 is already there. The derivative of ln of something becomes simply 1 over that. Plus 3 multiplied by the derivative of inside, which is simply 2x. And then minus 1. Now, if I have to rewrite this one, then this becomes 4x all over x squared plus 3 minus 1. But we are looking for relative minimum or relative maximum. Since the denominator will never be equal to 0, the f prime is defined for all values of x, from negative 3 to 5. And can this ever be equal to 0? Then all I have to do is simply 4x over x squared plus 3 will be equal to 1. That means bringing this one over to the other side, we get to realize 4x must be equal to x squared plus 3. That means 0 equals x squared minus 4x plus 3. Here we can easily factor this one. X minus 3, x minus 1. That means x has to be, what do we call that? 3 or 1. In fact, both of these values are within the boundaries. We need to do the number line. Here we have 3, we have 1. Here we have 3. Since the first derivative can be expressed in this way, let's see. If you have to plug in 0, then top becomes 0, so therefore we're going to get negative numbers. When 1 through 3, if you plug in 2, here the numerator becomes 8, denominator becomes 7, so 8 over 7 minus 1 becomes positive. And the last portion, above 3, let's say if you have to plug in 4, then we get 16, and this portion becomes less than 1, minus 1. So therefore this portion becomes negative. Then relative maximum here, negative to positive, that means this portion we're going to get minimum, relative minimum, and here we get relative maximum. That's what we end up getting by the number line. So when x equals 1, we get relative minimum. When x equals 3, we get relative maximum. All right, let's go for B. Inflection point. How are we going to find the inflection point? In fact, what we can do is we have to find the double derivative. Now, since our first derivative looks in this way, we just have to take the derivative of that. And we obviously have to use the quotient rule here. We have x squared plus 3, denominator square. Now, here first we're going to be getting the derivative of 4x, which is 4, times x squared plus 3 minus 4x and derivative of the bottom, which is what, 2x. And derivative of negative 1 becomes 0 anyway. So if you have to simplify this one further, we get 4x squared plus 12 minus 8x squared divided whole thing by x squared plus 3 entire thing squared. Then here we end up getting negative 4x squared plus 12 over x squared plus 3 squared. Now, this will never be not defined over negative 3 to 5. So therefore, only possibility which we can have point of inflection is when this one is equal to 0. I mean, since denominator will never be equal to 0, we get to realize that as long as the numerator is equal to 0. In other words, we get to see that 4x squared, negative 4x squared, plus 12 has to be equal to 0. That means we get to realize that x squared must be equal to 3. That means x will be equal to plus or minus radical 3. Now, in fact, positive and negative of radical 3, both of them are, in fact, within the domain. And you can easily see that this can be negative radical 3. This can be positive radical 3. And only portion where this will be positive is in between these two, such as when x equals 0. So in concavity is negative, positive, and negative. You can plug in each values and figure it out. But as you can see, at each predicted values of x, we get to see the points of inflection. When x equals positive or negative radical 3. That becomes our answer. Now part C. Find the absolute maximum of that value. In order for us to find the absolute maximum of that, what we have to do is check up on the endpoint along with potential max points. So we are looking at negative 3 and 5 and then 3. Let us compare all three values. Negative 3, 3, and 5. Now, once you plug in those values in, what we get to end up getting is this. 2 times ln of negative 3 squared plus 3 minus negative 3. I believe that is the expression. All right. Now here we end up getting this becomes 9 and this becomes 12. So we have 2 ln of 12 plus 3. Now if you have to plug in 3 in place of these two locations, then we'll end up getting 2 ln of 12 minus 3. So obviously, this one is smaller than this one. So this one is out. An absolute maximum we are looking at. And the next one becomes here. In place of negative 3, we have to plug in 5. Then we end up getting 2 ln of here. 5 squared becomes 25. So 28. And minus 5. In fact, to see which one is bigger, one thing which we can do is put it into the calculator, or another thing which we can do is simply to compare. 2 ln of 12 plus 3, and then 2 ln of 28 minus 5. So we can add 5 on each side and subtract 2 ln of 12 from each side, and we end up getting 8. And then 2 ln of 28 minus 2 ln of 12. Then here we end up getting 8. And then 2 ln of 28 divided by 12. Now this is barely this is about e value, which is this is less than, we get to realize is this is less than 2 times ln of e squared, which this portion we get to realize that that portion is equal to 2. So this one is in fact less than 4 compared to 8. That means our answer is this one is bigger, therefore this one is bigger, therefore this one is bigger. So our biggest point here would have been when x equals negative 3. Alright, so this is part one. We're going to continue with part two later. See you guys later.